Hello everyone. So welcome to ICN Introduction to Computer Networks. Today it is October 6th. We finished the discussion for email. This one. Therefore, let us continue to have the discussion about DNS, Domain Name System. In shorthand, it's DNS. Well, so let us think about the possible scenario with people. We have many identifiers. That says we have many IDs. We can have Social Security ID, SSN, so Social Security number. We have a name. We have a passport number. This is a scenario in the real life. And how about the possible situation in the internet? We have a house. We have routers. For this kind of situation, actually we have IP, Internet Protocol Address. So we have IP address. If we have IP address IPv4 version 4, then we have a 32-bit long IP address. And this is used for addressing the datagram. And in fact, we have a name associated with the host. So we have a name as well. And we have IP, something like we have the number. And we have a name for the host. For example, we have the name for this machine, cs.umass.edu. Well, similar to the real life situation, we have IP and we have a name for their host. And we have this kind of question. How to map between IP address and the name, and vice versa. That says if we have IP, can we find the name of the host? Or maybe given name and how to find the corresponding IP. So this is the current question. To solve the question, actually we need to refer to DNS, Domain Name System. Well, DNS, how to implement DNS? If we want to implement that one, actually we should have the database for possible lookup. Well, possible lookup by the DNS, so how to have that one? It should be the distributed database. And this distributed database is implemented in hierarchy. Well, so we have the hierarchy of name servers. All right, so we have the database, and actually we will have the hierarchy of multiple name servers. So based on that architecture, well, this kind of DNS actually in the current chapter, we talk about application layer protocol. So it's the app layer protocol. We have a host. We have a name server. Host and name server need to communicate to resolve names and address. Alright, so the current DNS actually is one of the app layer protocol. Right? App layer protocol. And actually we made the code to be simple. So of course we will push or try to move the possible complexity to the network edge. So we have a somewhat complicated working mechanism at network edge. Well, DNS again. Data check service provided by DNS, and also we will check the structure of DNS. First of all, service of DNS. We have a host, alright, and we want to map name to IP. So we have name to IP translation. So this kind of service is one of the service provided by DNS. And next one, editing. Editing, someone like also name, also known as. Alright, so this is the alias name. So we have editing. Editing actually we have alias name. So a different name. And canonical name that says it is the formal name. So editing. We want to know the canonical name and the alias name. So we have two possible names. And another one is mail server. We still want to have editing for the mail server so that we have the service we called mail server editing. And next one, we want to have the load distribution, where we have the possible application of the load distribution. Here, we want to have web servers. All right, and we can have many IP addresses corresponding to the same website. And we want to choose one closer to the client. And how to do that? So this is a service we call load distribution. Why it is called the load distribution? Because we want to share the load to the network edge, and so that we can find a suitable server with the proper IP, and so that that one can provide the web service to those hosts. Well, previously we didn't know we should have the distributed architecture, but why not? Why not centralize DNS? All right, so why we don't want to have the centralized DNS server? Because of these reasons. The first one, single point of failure. And the next one, if we just have a single DNS server, then we will have the concentrated traffic volume. So that one we don't like. And also we have the centralized one. So we will have the distant centralized database possibly. All right. And because of the centralized DNS, so we should have the proper maintenance. Here we have 4 reasons we don't want to implement the DNS in a centralized manner. Rather than we will have the distributed database as mentioned in the previous page. Well, so if we consider the 4 factors, and based on the 4 factors, actually we have the proper reason we don't accept that one. And why within that one we don't want to accept? Using a single, maybe a single term, it says, it doesn't scale. Because of the 4 reasons, then it doesn't scale. So we don't want to pass on the centralized DNS. Instead, we want to have the distributed DNS. All right. So it says if we talk about the possible volume, here we have the volume. If we talk about the current volume, something like this volume, if we have a single one, then the volume is really huge. So to have the scalable consideration of solution, we want to have the centralized DNS. So sorry, to have the distributed DNS. So we have a distributed hierarchical database for DNS. Well, we have a root. We have the currently we call .com.org.edu. Here is the TLD, top level domain name server. And actually we have for example, we have edu, for example, this one, this university, and this university. And for org, we have this organization, or for .com, we have Amazon. So we will have the next one, authoritative. For example, Amazon, we will have the authoritative DNS server. Well, this is the distributed hierarchical database. We have the root DNS server. And only a single one? No. Maybe we have multiple root DNS server. And then we have a TLD DNS server. And then authoritative DNS server. So let us look at the current possible scenario. We want to have IP, all right, and looking for Amazon.com. Let us have the first version. So here the version we call the first approximation. Client query the root DNS server to find .com DNS server. That says, oh, okay, it seems to be we can ask root name server. And root name server think, okay, the current one is .com, so ask .com. So we can query .com DNS server to get where we have the authoritative DNS server. It should be Amazon.com DNS server. And once we have Amazon.com DNS server, so we can query Amazon.com DNS server to find the IP. Well, the first one is seems to be we try to find from the root. Well, because of root, so let us check root name servers. So only one? Actually, no. Actually, we have multiple root name servers. Well, official content of that result, and actually we have the name. And it's really important. We will have that one by using the first approximation. All right. If we don't have that one, sometimes we cannot work properly, right? And of course, because of the importance, so we will have the possible attack. So we will have the security. All right. And currently it's name, and also we have a number. So it will be controlled by ICN, Internet Corporation for Assigned Names and Numbers. So ICN will handle DNS because of a name, right? And to handle that one, how many? We have 13 root name servers. All right, and actually we have US, and we have the other area, and we have the root name server in Asia. So we have 13 root name servers, not a single one. And actually TLD, top level domain name server. We don't know we have .com, .org, .edu. Actually, we may have the others. And these we call TLD. And actually, how to have the registration for authoritative? Actually, we can have one company called Network Solutions. And Network Solution provide the registration. All right. So we will have one company or maybe one to solve it. Here we call Network Solution. And for example, the .edu and the others. So we have the proper registration, then we will know where we have the possible servers. And later we will have that example as well. Well, so we have TLD. And next one, we have the authoritative DNS server. And this one actually provided by the organization itself. So we have an organization on DNS server, and that one we call it the authoritative DNS server. And that one can provide name and host mapping. Well, it will be maintained by the organization. Or maybe we will have the service provider. Service provider will maintain that one. Well, so what that means, authoritative, this one. Well, within the hierarchy, actually we have a root name server. We have the TLD name server. We have the authoritative name server. But do we have the local DNS name server? Well, we don't find it within the hierarchy. So that says local DNS name server. It does not strictly belong to the hierarchy. No, we don't talk about that one, but we will use it. So here we mention possibly we have a local DNS name server. And for each ISP, for example, residential ISP, company ISP, university, and then we will have one, and then it is called the default name server. And that default name server we call it's the local DNS name server. Well, so if we have the host to make DNS query, where the query will be sent. In fact, we send it to the local one rather than root. All right, rather than root. So we send it to local DNS name server. So if we have the function or the possible function of the local DNS name server, then it can take the responsibility to resolve the possible query. Well, if we have the local DNS name server, then it possibly have the local cache. And so that we have a name to address, or maybe vice versa, address to name, translation pairs. All right, and the local name server, it acts as proxy, and so that it can forward the query to the hierarchy or respond to the host. So this is a possible way to resolve name and IP. And we have two types of query. And the first one, it is called iterative query. And second one we call is the recursive. And later we will have the term recursive. And let's check iterative query first. So we have a host. All right, and the current location, NYU. Possibly we have the engineering maybe department. So we have engineering.nyu .edu. We have IP, current name. All right, so we have two. One at NYU and one want to find the IP address for the current host. All right, so name to find IP. So we want to send a request from the host at NYU and send it to the local DNS server. And local DNS server, where to send the query? Yes, to the root. So initially, we don't have the query to be sent directly to the root DNS server. Instead, we send it to the local DNS server and serving as a proxy. And currently, assume we don't have any possible cache. So we will send it to the root DNS server. And previously, we didn't know root DNS server, then we'll find the corresponding TLD. So asking where we can find, for example, this one. It says, oh, okay, TLD should be the .edu. So it says, okay, later we will find .edu. Where to find? You ask the TLD. All right, for example, .edu. Okay, once you ask .edu, then where to find the NYU.edu? So we find the authoritative. Oh, okay, this is authoritative .NYU. Oh, sorry, UMass, not NYU. So asking the authoritative DNS server of UMass.edu. You see this one. And if we have the authoritative DNS server here, then we can find a solution. So we should find the answer solution. All right. Okay, so this is the possible way, and this way we call iterative. And this kind of iterative, we can have the following way to have the interpretation. Well, once we ask root DNS server, it says, I don't know the name for this one, but you can ask the next server, this one, .edu. So .edu TLD, and likewise about the UMass.edu, I don't know that one, but you can ask this one, the authority of UMass.edu. And yes, it's that one. So for this one, asking this host, then we will have the solution. So that's why I already have the solution here. So previously for step 1, no solution, but you can ask this one. No solution, but you can ask this one. So finally, we have the authority, so we can have the mapping, and the mapping that we have the solution. All right, so this kind of a query we call it's the iterative query. Actually, we have another one. It's called the recursive query. Recursive query, it says we put burden of name resolution on the contacted name server. That says it's root name server. So here, asking direct the query to local one and send a query to root. And then root says, okay, I will find the solution for you. So root name server will send the query to TLD. And same for TLD, okay, I will find it for you. So send it to the authoritative DNS. And then we have the solution. Okay, mapping answer. Find the answer, return. Find the answer, return. Find the answer, return. So this one, it is called the recursive query. Why recursive query? Because we have the similar function at the root name server, at the TLD name server. And so that return, get the answer. So we can return, get the answer, and return the answer. Well, so this one, in fact, it is a recursive manner, so we call the recursive query. Well, if so, this kind of a query will have a heavy load at the upper levels of the hierarchy. That says, how about root? We have the heavy load, or maybe the heaviest load there, and next one is TLD. But it's really, here it's really easy. Send a query from the local DNS server, and that root will find the answer, so that the answer will be returned to the local DNS server. And likewise, once we have the solution, well, it will be returned to the host. All right, so this is the second query, recursive query. So let me have the clear page for this one. We have the solution. Finally, solution. That says we find the mapping. So actually from step 5, step 6, step 7, step 8, we find the mapping. And so that we return the mapping to the host. And previously we don't have any cache. So no caching. But similar to web caching, is it possible to have caching? Yes. And so that we will have caching and updating DNS record suitably. So you see, if we have the technique of caching, once any name server learns mapping, all right, it caches the mapping. All right, once we have the cache, actually we will associate the possible time duration with the cache entry. All right, and so that we set time to live, TTL, to that entry. And if we have a time lasting longer than TTL, then that entry will expire. So it will expire, or it will be expired. And while we can have the cache, it says TLD servers, and the servers will be cached in local DNS server. Why? Think about the hierarchy. Root, even it should be the role to take the responsibility to resolve the solution. But the important one should be TLD. So we should know TLD to have the further query. So normally we want to have the TLD server to be cached in the local name servers. If so, then we can bypass root name server. All right. Okay, so if we have caching, then of course we will have cache entries. But sometimes they may be out of date. All right, so you can keep, but they may be out of date. All right, so we expect to have a TTL, and why we have a TTL and suddenly we have out of date? Because we cannot keep it permanently, because name will change IP, so it doesn't mean we will have the mapping permanently. So we should have the TLD associated with that one. And so that we think that is a reasonable time duration to have the possible mapping duration. All right. All right, so of course we will expect caching. And previously, talking about the previous query, don't have any caching. So we just follow the standard procedure to have the DNS query. And right now, if we have a caching, then we can bypass, for example, root name server. All right. And actually, we have the standard for DNS to have update and notify Authentication mechanism defined by RFC 21 and 36. So this is the update and notify mechanism. We have the distributed database, and the database store the record we call resource record. In shorthand, we have RR. And the record actually we can have the general format to have a full tuple. And this full tuple, we have a name, and we have the value. We have a type. We have a TTL. All right, and let's check type first. Type actually can be A, address. So, A, address. So we have a name. Here we have a name. Name actually is host name, and value is the IP address. So if we have a type equal to A, then we have the mapping, name and IP. So we have a host name in the field of name, and we have a value to store the IP address. And if it is NS, that says we have name server. So we have a name. Name is the domain, and the value is the host name of the authoritative name server. So we have the domain and the authoritative name server for that value. And C is canonical. Okay, canonical name, and this is a real name, the formal name. And here, name is the alias name for some canonical real name. And the value actually is a canonical name. So name is the alias name, and the value is the canonical name. And here, this is a mail server. So we have the name is a mail server, and associated with the name. So value for MS is the mail server and associated with some name. Well, canonical, I don't know. It should be the formal, but you can look at the current term interpretation. Well, DNS records, actually we want to have the possible message sent through the system to exchange. So we have a query, all right, we have a reply, and we have the following format for query of the reply. So we have an ID, we have a flag, ID here. And we have a flag. Flag, oh, it's a query, oh, it's a reply. And mention recursion desired, recursion available, or reply is authoritative. So we have a flag to denote these. And we have questions answer. Authority RR and additional RR and etc. So we have questions, answers, authority, and additional information. So we have the corresponding number. Well, query and reply. And here we have the further possible fields. All right. Follow that format, we can have the query and reply. And right now, let us have the possible example. The possible example we have an IP address and the authoritative name server. So we have an IP and the name. And we have the domain authority and for that domain. So how to use the previous one? Actually, we have address mapping. So IP and the name, you see? And the IP and name. So here name, this one, actually we have a network utopia. So this is a domain. So based on the previous one, actually we will have these. We have an IP mapping to the name. So we have an A first. And we have an NS. NS name is domain. So actually we follow A and NS. And this one. So we have the two fields. So this one. So maybe something wrong with my pen, but I emphasize we have NS here, and we have A here, and we try to have the two fields insertion. All right. So first of all, create authority name server with the IP. Right? So IP. And we type A record, this one. All right. And also we have the name server. All right. And possibly maybe we have the mail server. So we can have the insertion of MX type as well. But we have A first and then NS. If necessary, we have MX. All right. And for DNS, actually, we should have the security. We already know DNSSEC. Why we should take care of the security? Actually, we have the possible attacks. DDoS, denial DOS attack. It will bombard the root. Okay, will bombard the root. So, bombard the root name server. But it will be a successful attack? No, not successful. Because we can have the traffic filtering, then, oh, okay, now, okay, so we will filter out this kind of attack. And also, if we have a local DNS to have the cache of TLD. So it won't be necessary to visit root name server. So we can skip the root name server, and then even you can attack the root name server. It doesn't matter. So it won't be a successful attack if we want to bombard the root name server. However, how about we change our mind to bombard TLD server? If so, then it's a problem. So potentially more dangerous. So this is the first one, DOS attacks. And next one, redirect attack. So we will have a man in middle attack. And the main immediate attack is just try to have the way to intercept DNS query. Intercept DNS query, then maybe try to have the possible manipulation. And so that we have this kind of redirect attack. Or maybe we have the DNS poisoning that says send bogus reply to DNS server. And so that wrong, right? And wrong, then we will have the wrong cache entry. So this kind of redirect attack we call DNS poisoning. Well, so we have a DOS attack. We have a redirect attack. And furthermore, we want to know more, exploit DNS for DNS. And we may have the query with spoofed that says the fake IP address. And then, because of the fake one, then we can enable the possible denial of DOS. So that says send query 1, query 2, query 3. So we should have the spoof IP address. So once we have multiple spoof IP address, then we can send a lot of query. And previously we didn't know we have a botnet. Botnet then will use the spoof IP so that many nodes can send the query to the root name server. And so that we have the denial of DOS attack to the root name server. And we can bombard the root name server for sure. Right? So we have some issues within the security. And actually all will be well taken care of by DNSSEC. You see? So we have a standard, and that standard can well take care of the issues of security for DNS. All right, so this is the first one, DNS for today. Well, possibly let me pause here for 1 minute for you to think about the current discussion by the field of DNS. Okay, so 1 minute later, I will continue to share the next topic, P2P applications. All right, so of course, I just let it have 1 minute to think about the previous discussion for DNS. And right now, let me move on to the next one, P2P applications. Peer-to-peer, that says P2P. We will have an architecture. And this kind of architecture, normally we expect no servers, at least no always-on server. So arbitrary end system can directly communicate with each other, and those they call peers. And peers request service from the other peers. Well, so we have this kind of architecture to provide service, and this kind of service we call P2P service. Why we want to have this architecture? Because we will provide self-scalability. All right, self-scalability, and we can have more peers, and more peers can still request service from the system. And the system can provide the service to that peer, the newly added peer possibly. So we have new peers bring new service capacity. That says, all right, we have the first tier, the surrounding tier, and then we can provide service to the other peers for the outer peers, possibly. So we can have the next one, and so that we can expand, then this one meet the feature of self-scalability. So that's why we prefer this kind of architecture, P2P architecture. Well, peers actually should we ask peers to have the permanent connection? No. Peers are intermittently connected to the internet, but maybe no, so that they will change IP addresses. And if so, then we don't have the easy way to maintain. So we will have the complex management for P2P. And possible P2P, we have file sharing. File sharing provided by BitTorrent. And we may have streaming provided by ConCon. And actually, previously, we have VoIP. And VoIP provided by, for example, Skype. Even right now, we don't have any service provided by Skype. But in the past, actually, yes, Skype provides the P2P service. Specifically, the P2P service is the voice over IP service. So we have a P2P so that we can have the proper scalability. Because of this, we have a P2P. And later we will have some possible way to consider why we want to have a P2P. And so that we have the comparison between the two architectures, client-server architecture and the P2P architecture. And here we want to find the time. How much time to distribute file with the size of f from one server to n peers within P2P. And later we want to know the similar scenario in the client-server architecture to find the corresponding time. How much time to distribute a file with a size of f from the server to the peers. So think about the current scenario. We have a peer to upload or download capacity limited resources. So we have upload capacity U, download capacity D, and we have different capacity for 1, 2 to n. And we have a server as well. So server will upload, all right. So current capacity for server upload. And here we have the one of the user. So the previous assumption, upload the file and then, you see, distribute a file from one server to n peers. So how to have the calculation? Later we don't have the end-to-end delay derivation, we try to find the bottleneck. All right, so the server transmission. Server will, or maybe must, sequentially send, upload n files copy. All right, because of n, so n file copies. So time to send one copy, the time is f over mu s, because we ask the server to distribute the file, the same file, the identical file. So to n server, we need to send n copies, so nf over mu s. So for the time, we will have one component, this component. We try to find bottleneck, so this is one component. So here we have one component. Of course, plus the others, but right now we just care about the bottleneck component. So we have nf over mu s, so this is the first component. And next component, we have the possible time to download. So we use this one to download. The minimum to download, so that says it takes time, the longer time. And so that download to the client cell. So time to upload, n copies. Time to upload, slowest one. So we have time to upload and time to download, smallest one. And we'll just find the bottleneck. So this is the time of a bottleneck. And so that this one at least. So we have the time at least should be the quantity of the bottleneck. So for client server, for client server mode, we have this way because server upload and then download by the server. So this is the first time. However, for time distribution using P2P architecture, so we have these. It doesn't mean we ask server to finish the transmission. Instead, we have the server at least send one copy. As for the others, you can help yourself. So help yourself. So first one, just one copy. And of course, we have the smallest rate to download. And as for the distribution, actually n file jointly served by the server and all the peers. So we have this one. Download, we have a bottleneck here. And as for upload, actually server will help and the other host will help. So we have this will help. And all helps for n copies. And likewise n copies, so we have the time. So the time here should be one copy from the server and then we will jointly serve by the, currently we have a server already. And we have the other uploading capacity by the other peers. So jointly have the NF, that says n copies, by the P2P. Likewise as this. So if we have the current formula, try to find the lower bound. And here is the lower bound. Using the lower bound, we can have the plot. So this is a plot. of the lower bound. And lower bound, we have P2P. And we have a client server. So the lower bound of client server higher than lower bound of P2P. So we think which one will be the efficient one? We think P2P will provide the efficient one for the current situation. So that says, talking about the current example, we have file sharing. All right, and this one will be better. Okay, so maybe let me stop here and later I will continue.